Okay, today we're going to talk about the standard normal distribution and the standard normal table. So we're going to use this if we have a normal distribution and we're asking about something that's different than like one standard deviation from the mean or two standard deviations from the mean. So we standardize our data using z-scores to have a mean of 0 and a standard deviation of 1, and we just use this z-score formula. Okay. It says if a variable x has any normal distribution, then the standardized variable, which would be your z, has a standard normal distribution. Okay, this only works if the original variable is normal. If it's not normal, it doesn't work. Alright, we've got our mean here now, which is 0. We're 1 standard deviation, 2 standard deviations, 3 standard deviations, -1, -2, and -3 standard deviations. Our 68, 95, 99.7 rule is still true. Alright, but we're normalizing, or we're making it standard using z-scores because we're probably not going to ask a question that is as straightforward as 1 standard deviation, 2 standard deviations. Okay, so what I mean by that is we're going to use something like this. If we get a z-score, which would be not a whole number, not 1, not 2, not 3, we can use this table A in the back of the book, to find the area. Okay, it says a table of areas under the standard normal curve. The table entry for each value z is the area. Oh, well, there's a typo. Way to go, Kissel. Is the area under the curve to the left of z. So if you're looking at a curve, and let's say this is our z-score, this entry will tell us the area under the curve to the left. Alright, so if you're looking at this as just a little snapshot of the table over here, okay, going down this way is your tenths, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, alright, and then going across this way is your hundredth place. So if I was looking at z equals 0.52, the value that I would want to look at is 0.5. Oh, that is not good. I do not like that marker. I'm sorry. 0.5 and 2. You see where those meet? The area would be 0.6985. Alright, real quick, here is what the table looks like in the back of the book, Table A. This is always given to you on a quiz or a test or on the AP test, alright? So it goes up to you can see your z-score goes to -3.49. Alright, so that would be a z of -3.49, or -3.49 standard deviations from the mean, very far away. Okay, and then it goes all the way to 0 on this one. Okay, that's the first page. Alright, so you can see you need to flip to this page in your book or in a book because you're going to need this the rest of the day. Alright, these problems. Find what percent of the data in a standard normal distribution is below. Include a sketch of the standard normal curve and where your z value falls. Alright, so if we're doing z equals 1 and we have a standard normal curve with the mean right here, 1 would be, okay, we've got 3 standard deviations on either side. Z equals 1 would be exactly right here, 1 standard deviation from the mean. If we're looking at z equals 1, we're finding the area to the left. Okay, so this is the area we're trying to find. Alright, I'm going to go back to my page of the book so I can see where z equals 1. Where z equals 1, if you looked on that table, you would have seen that the value was 0.8413, which means 84.13% of your data is to the left of z equals 1. Okay? I want you to try to do these without me. Try to do these without me, so I'm going to put them up here just so you have them, but you should be trying these. Okay, so z equals -1 would be 1 standard deviation from the mean. The area would be to the left. it would be 0.1587, okay, which is 15.87%. Z equals negative 1.8. Here's the mean. 1, 2, 3. 1, 2, 3. That would be like right here. We're going to the left here, not very much area. And we get a value of 0.0359, which as a percent would be 3.59%. Okay, last one, 2.35. 1, 2, 3. 1, 2, 3. Draw a curve. Alright, 2.35 would be about here. Alrighty. Oh, and I just made a big mistake because it's not to the right, it's actually to the left. So let me undo that. 2.35 to the left. Sorry about that. 0.9906, which is 99.06. That's how you use Table A in the back of your book. This next question, find the proportion of observations from the standard normal distribution that are between negative 1.25 and 0.81. Always draw out a picture. 1, 2, 3. 1, 2, 3. Hopefully your pictures look better than mine using a stylus on an iPad, hopefully. Negative 1.25 would be about here. 0.81 would be about here, and we want to find all the area between. Alright, if I go to my table A, Z equals 0.81 and Z equals negative 1.25. I want to find both of those. Okay, this gives me a result of 0.7910. This gives me a result of 0.1056. Alright, so they have this overlap, which would be right here, because this finds the area to the left of 0.81, so from here all the way down. And this finds the area from negative 1.25 to the left. Okay, so that's your overlap. So all you have to do is subtract these. 0.7910 minus 0.1056, and you get a result of 0.6854, which means 68.54% of your data fall between negative 1.25 and 0.81. Alright, last one I'm going to show you today. Find the z-score that corresponds to the 80th percentile. 80th percentile would be 0.8000. So you need to go to your table A. You should have table A out. If you do not, you are not going to understand this. Go to table A and find in the table where you see 0.8000 or the number closest to it. Okay, when I go to the table, I see a value of Z equals 0.84, which is a value of 0.7995, which is the closest I can get to 80th percentile. So that is the z-score that is closest to the 80th percentile. Best of luck. Try some of the homework. I think you can do it.